In this video, we're going to look at images formed by spherical mirrors. This is how the simulation appears when you first open it up. We can see right now we have a concave spherical mirror. This over here above the O is the object. I don't know what it's supposed to be, but it's a green pillar with a pinkish dot on top. And we can see that we have some rays coming from it, going to the mirror and reflecting off and coming back. At this location marked with the I is the image. Two other points to note. C is the center of curvature. If the mirror were a circle, that would be at the center of the circle. So the distance between C and the mirror would be the radius. In the course materials, I actually call that point RC for radius of curvature. It's the same point. At half that distance is the focal point of the mirror. So here's F. The focal point is the focal length away from the center of the mirror. If I take and move the object further away from the mirror, wrong way, we see that the image moves the opposite direction. Right now I would say that we have a real image. I could put a screen there. It is inverted. Notice the object has the pink above and the image has the pink below the principal axis. And it is smaller. The object is much taller than the image, and that is more apparent as I move it further away. If, however, I bring the object in so that it is between the center of curvature, the radius of curvature, and F, I see that I still have a real image, but now it is magnified instead of diminished. It is bigger instead of smaller. And lastly, if I bring the object in between the focal point and the mirror, I see that my image is no longer real. It is virtual. It is behind the mirror. It is upright. The green is going up in both cases. And it is larger. No question. Let's now take and look at what happens if instead of a concave mirror I have a convex mirror. So now we see the radius is -8. The focal point is now at -4. It's still half the radius. If I take and move the object around, we see that the image is always virtual because it's always behind the surface of the mirror. It is always upright and it is always smaller.